Hello, thank you all for being here. Good afternoon. Today I'm going to tell you about an experiment, a superpower story, as all superpower stories start with a science experiment, some mad scientist. And I will tell you a little bit about our experience with the MCP and what we actually managed to do with this technology, which is really young because the first came out in November 2024 from Anthropic. I'll be very quick in this initial part because anyone who knows the subject knows how events unfolded. Anyway, in November, Anthropic released these specifications which promised some very interesting things, including the possibility of interconnecting AI agents with external tools in a standard unified manner. The USB of AI was defined. In the spring, finally came some confirmation that the adoption was not only of Anthropic and thus the world of cloud AI, but also of Google. AWS and the other OpenAI players decided to adhere to this standard. And so for us, it was clearly the input to say that it is indeed becoming an accepted standard. And so we started our studies in this area. In June, we did our first proof of concept. We did a little experiment. Here in this screenshot, you see a small chart from VS Code, which for us was the most practical tool to basically integrate an MCP within a fast development pipeline, especially in the development of the MCP server itself. We initially integrated only two services. One of our API services that gives the exchange rate updated in real time, and a service that normally serves to take very different Chamber of Commerce visas. There is a reason. It was to understand this technology well. One thing that emerged immediately was how effective it really is. So our test showed that the setup was practically instantaneous. We were talking about two parameters. The address of the MCP server, in our case, mcp.openapi.com, and the authentication token of our API. These two parameters configured in the case of e.g. VS Code within a JSON file that is placed in a particular place. In the case of other clients such as Cloud, for example, a small JSON file to be placed in a specific directory, but it made everything extremely simple, and from the first test we actually saw that it worked. So having validated the initial test, we decided to go ahead and do some more experiments. In July, after an extensive test session, we started to see some interesting behavior emerge, i.e. the result, but above all, the reasoning process was profoundly influenced by both the agent used and the LM selected. So by testing the various clients on the market, we realized that this process could be extremely complex and satisfying from the point of view of use. In this example, there is a small video that more or less shows what happened. We asked for a difficult thing. I live in Terni, so I like ice cream, and I asked if I am from Terni, and I would like to invest in an ice cream parlor. Give me some indication. In an automatic way, as you see from this small video, the system made a series of calls to our APIs, which also have 70 parameters. But as you see from the initial question, the question was, I want to invest in an ice cream parlor. Independently, it understood which set of APIs to use, in which order to implement them, and produced a report. I'm not going to buy an ice cream parlor, but if I wanted to, in a minute and a half, I got a very thorough report. A market survey based on official data, Chamber of Commerce data, credit risk data, geolocation, all the individual APIs that were implemented within the MCP that could serve the purpose of the request I made had actually been used, producing a result that clearly is not easily determined upstream, because this reasoning process was the prerogative of the agent used. So we performed further tests with other variables in play. Here you have, for example, an example with Gemini client. So for example, the use in scripting, so bash scripting or otherwise automation processes. And it has to be said that it worked very well in the same way. Always selecting a language model sufficiently evolved to perform a series of tasks. In this little experiment, we always ask Fermi, I don't remember, I think pizzerias, make me a CSV with a list of pizzerias and give me, for example, the PECI box and address. Now, I don't remember is what we're going to ask in this case. What happens is that actually this thing is done. And from the implementation point of view, as you can see from this test, there is nothing. We simply asked a question in natural language, and the implemented API sequence was completely chosen by the LLM. What we were interested in was that the end result was indeed as expected, and therefore the formatted CSV file was produced as we requested in this. Also not too detailed. Create a pizzeria CSV file with the PECI address of the pizzerias interni, very generic. Search the database for pizzerias, what echo code a pizzeria has, what is meant by pizzeria also in restaurants. The output we got is exactly what was needed. Independently determined what the echo codes of the pizzerias were, or if the result produced was not satisfactory enough, did searches by text with the word pizzeria. Normally pizzerias have the word pizzeria within the name and can be an interesting strategy. The thing that emerges therefore is that the combination of queries but also the descriptions within the API MCP server are decisive. So we started to work very thoroughly on these descriptions on the semantic part. The big work was explaining to a stupid person what our APIs do, what the parameters are, and give advice to this person on how best to use them. Use the dry run parameter to perhaps get a quote before searching. If you only need to count, it is useless to enrich the data with too much information. Just take the information of the number of records. These strategies are completely the prerogative of the LLM. Having finished this extensive series of tests, we decided to go into production with version 1.0 of our server. We decided to collect in the repository all our experiments and all configuration guides for the main LLM engines and LLM agents, and we started to work in concert with some of our early adopters who decided to test with us this technology of which we had limited knowledge up to this point too. Because as often in this sector, in the AI sector it happens, there's this black box where you don't really know what's going on inside, and it's always a bit complex to have a repeatable and clear result. Now, downstream of these tests, we have a moment. I have summarized here a series of examples on small things, these small powers that we can go and give to our agent. Here is an example of verification of an IP address can then insert within a request or a pipeline a check on the world database of blacklist of IP address and get, for example, ratings. Here you see, for example, that there is a front score. There are a series of information that there could, in an automated process, help us to determine if, for example, the visitor is malicious. Verification of a mobile phone number, same thing when onboarding in our platform, whatever it is. I may need to collect the mobile number for an OTP discourse or for any other reason, verify if the mobile phone is somehow existing, reachable, what the operator is, or if it is on any fraud lists or anything like that. Similarly, verify an email address. We get a front score and can then insert this check into our process with the right question. Let's go on to something a little more advanced. So access official databases again via the services of OpenAPI, in this case, Automotive, starting with a license plate number or a database containing a set of license plate numbers, automate the analysis of these plates, figure out if the vehicle is insured, if it has a clean audit, or what type of vehicle. Now, it is not our role to figure out what is the use of these APIs. We provide these tools, and we noticed that providing these tools through an MCP layer enabled a whole range of users who previously had a classic difficulty. I need this information, but I don't have the IT department, or I need this information, but I don't want to develop or integrate your API because I would have to do a project on purpose. All these low-code and no-code profiles we have collected in this type of experience because actually even internally, the less skilled, I'm speaking from a technical point of view, internally are using these tools with us because they have access to our own APIs to do, for example, compliance checks and everything else without any technical knowledge. Technical knowledge, and it means that this tool is not a tool for people who have no technical knowledge, but is available to them. Then we will see some slightly more complex examples, exchange rate control, as we saw before, something more complex, advanced search with asynchronous official documents. In this example, we asked for the Chamber of Commerce certificate of our company from the name. The model automatically realized that from the name we don't get much. First, we have to do a search by name, obtain Chamber of Commerce data such as VAT number, CRA code, at which point I can actually request a list of available official documents and download the document. Okay. The document, unfortunately, is not available synchronously, but the system automatically understands this very pernicious aspect and did a check after a minute or so to see if the document was ready and then actually downloaded it, completing the request as I had requested. All this was done automatically. The sending of an SMS, and then include within these processes also things like this. Searches on official postal cap databases. We know that caps change periodically. In our analyses, we often see problems with cap matching because there are actually almost imperceptible variations in these caps. Merging of municipalities and in some processes, such as the invoicing, are a very important reason for rejection. So in our Bs, there is also the official cap database that is in the post office, becomes available. And as you see in this case, we asked for information on Busto Arsizio and got details of the municipality. What do we do in the next step? Geocoding, but this municipality, actually, what is the town hall? What are its coordinates? And then we can go on to slightly more complex things. Here we ask to find all the pharmacies within a radius of 10 kilometers from the town hall of Busto Arsizio and put them on a map indicating the number of employees. We start to get onto slightly more substantial things. You see the process was started with geocoding, then the town hall to find the exact coordinates, going through a search by radius of the companies from those coordinates, specifying in this case the ATECO code of the pharmacies, at which point the search was refined with other search criteria, and this interactive map was produced all in the time of 50 seconds to 1 minute. Most of the time was clearly not for API calls, but for generating the HTML code of the map. But this inherently depends on the type of model, the model used, and the tool used. Moving on to something even more complex. A partner of ours has produced software that is currently in use in the testing phase. A software that makes it possible to analyze the compliance of tenders submitted by companies for this public administration. These tenders are collected, analyzed, the compliance of the documents submitted is checked, and for each individual document, this software, by calling our MCP, obtains the document and the official information, checks it against what the company submitting the call for tender says, and does a pre-validation process, which took the analysis of a file for a call for tender in this API where we are doing this experiment from 2 days to a matter of minutes, because at that point, the operator only has to do a formal check at the end. All the documentation collection part has been automated. The beauty is that it has been automated without implementing dozens and dozens of APIs manually by a developer, the API for the list of companies, the API for official document X or Visura Y, but it was all coded within the MCP server descriptions. So this is more or less the state of the art. This is the current list of our implemented APIs in this MCP world. In this version 1.0, we needed it to clarify our ideas on this technology and to understand how much more we are going to invest in terms of resources and development. But what we are going to do with version 1.1, which we are releasing in a matter of days. In any case, by the end of the month, we will implement the entire suite of OpenAPI APIs. We are talking about over 400 APIs on practically all areas, from the ADAS world, then digital trust, digital signatures, timestamps, PEC, corporate searches, master data. There are so many that it would really take me a long time to tell you. The really interesting thing is that in the configuration phase, it will be the user who will choose which APIs to enable and make available for the authentication token. The authentication token that is then used within the MCP. Another thing not to be underestimated is that we have decided to release the entire MCP server in open source under the MIT license. So from release 1, we will release the whole thing because we saw that the real strength was in the API description anyway. And with many of our collaborators, we decided to start this work to improve. One, to give anyone a chance to drill down into the project, modify aspects that they might find useful to change, and build on these experiments of ours to implement other APIs as well. It's not a problem. The technology is simple. Like all simple things often have something brilliant in them. So in this case, it is not so much our effort in developing an MCP server, which is something I would say is within the reach of most of the developers who are here today. But instead, it is understanding the semantic part of the descriptions of these APIs, which we may know very well because they are our APIs. But we have often seen that it is our customers who then use them, who know exactly what they need and what the little blinders are that can be found within an incorrect description. I was so quick, I'm so happy at 5:30 p.m. We're playing a little game here at our stand if you're interested. It's a little challenge on how much you know about APIs. In this case, the REST API. There is a ticket up for grabs for the Web Summit in Lisbon, where we will be presenting our project. And with this, I thank you for being here to attend and see this excursion of ours, this experiment of ours, and I invite you to test this technology. It is also available in our sandbox, so without necessarily using real-world data credit. But I invite you to test it because there has actually been a lot of talk about MCP. Even today here at Codemotion, we have real-life experiments, so we are no longer in that realm of AI seen as a series of promises. These are things that are working now and they're within reach, really, either from a no-code profile or to a more skilled developer who wants to put it inside processes based on AI. And I thank you again. And I don't know if there is time for any questions. If there are any, I am at your disposal, or for any further information, you can find me at our stand right there. The OpenAPI one, thank you and have a good. Thank you.